Hello everyone, so today we are going to be going over 7.4, 7.5 notes. So 7.4, we're just going to build a little bit more on the stuff that we went over last class, just kind of see what you remember from there. And then 7.5 is getting into some more of those special parallelograms that we have and trapezoids. So first thing to kind of take note of, in our last class we talked about rhombuses, rectangles, and squares. And so to start off, we have another theorem about rectangles, and it is the rectangle diagonals theorem. This states that a parallelogram is a rectangle if and only if its diagonals are congruent. So again, just a reminder from last class, rhombuses, remember we have 4 congruent sides. Rectangles, we have 4 right angles. And then squares have to have both. They have to have 4 congruent sides and 4 right angles. So getting into our first example here, it says you are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can we assume that this is a rectangle? So again, remember the big thing we need for it to be a rectangle is 4 right angles. So when we look at this, we do see that opposite sides are congruent. So that does make this a parallelogram. And remember that rectangles are parallelograms. So it does at least follow the steps that we need. However, we don't know anything about the angle measures. So we would say no, we don't know angle measures. And to be a rectangle, we need 4 right angles. All right, and then part B says you measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. So remember the diagonals are these lines here that go across the middle of that shape. And in the theorem right above, it says in order for a parallelogram to be a rectangle, the diagonals have to be congruent. Well, in this case, they tell us that the diagonals are 54.8 and 55.3. So the question says, what can you conclude about the shape of the opening? So we know that it is not a rectangle. And you would say by the rectangle diagonals theorem, the diagonals must be congruent to be a rectangle. So our shape is not a rectangle. It doesn't ask us specifically what is this shape. It is just stating what can you conclude about this. And so that's where we need to put in the information about that theorem, just showing that we're using the knowledge that we know of how we got to our answer, and then giving an answer of some sort of, well, it can't be a rectangle because of this reason, and then showing that theorem that proves that. All right, so now we get into some math side of things. So it says finding diagonal lengths in a rectangle. So we know this is a rectangle. according to our theorem, rectangle diagonals have to be congruent. So for this first one, it says QS is 5x minus 31, and RT is 2x plus 11. Find the lengths of the diagonals. Well, QS is one diagonal and RT is another. Again, back to that theorem, these need to be congruent in order to be a rectangle. So the length of QS has to equal the length of RT. So we can say 5x minus 31 equals 2x plus 11. And then we need to solve for x. So we will subtract 2x from both sides. Oops. So we have 3x minus 31 equals 11. Add 31 to both sides. 3x equals 42. And when we divide both sides by 3, we get x to equal 14. So that was only part of it. We needed to find x, but then the whole question asked us to find the lengths of the diagonals. The diagonals are going to be the same no matter what, so we just have to take one of those equations and plug our x in. So I'm just going to take this 5x minus 31 and plug the 14 in for x. And when we do that, we get 39. So that means that our two diagonals are 39. All right, and then number 2 says, what if QS was 4x equals 15 and RT was 3x plus 8? So same steps that we just did, except just different equations to use. So this is a great time if you want to pause the video and try and do this one on your own, kind of see how you would do. So we will put these equal to each other. 4x minus 15 equals 3x plus 8. We want to get our x's together. So we subtract 3x from both sides. We get x minus 15 equals 8. And then we just add that 15 to both sides, and we get that x equals 23. Again, remember that's not all we have to do. We also need to find the lengths of the diagonals. Again, the diagonals have to be the same measurement, so it does not matter which equation we pick. I'm just going to pick the first one. So 4x minus 15, we plug that 23 in for x. So then we do 4 times 23 and subtract 15, and that gives us 77. So our diagonals have a length of 77. The diagonals are not in degrees, so you just write them out as the number they are. All right, so then next we get into our vocab about trapezoids. This is the next kind of special shape that we're learning about. And we have all of this vocab. So a trapezoid, to start with, is a quadrilateral with exactly one pair of parallel sides. Quadrilateral, remember, four-sided figure. So within a trapezoid, we have bases, base angles, and legs. So let me see if I can draw a trapezoid here. Oh, nice. So this is a trapezoid. This is what a trapezoid looks like. Your bases are the parallel sides of a trapezoid. So notice that this side and this side are parallel. This top and bottom are parallel. Those are our bases. The top and the bottom. Don't always assume the top and the bottom are your bases because sometimes your trapezoid can be sideways. Just know that your bases are your parallel sides. Your base angles are two consecutive angles in a trapezoid whose common side is a base. So, for instance, this angle and this angle would be base angles. Also, this angle and this angle could be base angles. And then your legs are the non-parallel sides. So in this case, the left and the right side are your legs. And then we have this idea of an isosceles trapezoid, which is a trapezoid whose legs are congruent. So they have the same measurement. That does not make them parallel, but if the legs are congruent and have the same measure, then we have an isosceles trapezoid. And then we have some kind of important terms that go along with trapezoids. So we have a mid-segment of a trapezoid. So this is the segment that connects the midpoints of a trapezoid's legs. And you will kind of see that at the end of our notes today, kind of what a mid-segment looks like. And then we have some theorems and a converse for you. So if a trapezoid is isosceles, then each pair of base angles is congruent. So if those legs are congruent, then base angles are congruent. The converse of that is if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So if your base angles are congruent, it's isosceles. If your legs are congruent, your base angles are congruent. And then the diagonals. So a trapezoid is isosceles if and only if its diagonals are congruent. So a trapezoid follows the same process as a rectangle when it comes to the diagonals. Remember, you can always pause this so that you can copy down those definitions, but for purposes of the video, I'm just going to keep going and get into some examples. So using these properties that we just learned about, we are going to find the measure of some missing angles in this picture. So it says the stone above the arch in the diagram is an isosceles trapezoid. Find the measures of angle K, M, and J. So they tell us that this top piece and this bottom piece are parallel. Remember, those parallel sides are our bases. So with our bases, we can find our base angles. Our base angles have to have a base side between them. So right now we just have this measure of angle L to be 85, but we know that angle L and angle K have to be congruent. So angle K has to equal 85 degrees. And then we just need to find M and J. Well, again, we know that M and J have to be the same measure. So to find them, we just need to find the measure of one of those angles. Well, remember that two consecutive angles on the opposite sides, so not in this case of our parallel side, but this L to M, that leg, those two angles have to add to be 180. So to find the measure of angle M, we would just do 180 minus 85. And that would give us 95. So angle M and angle L are 95 degrees. You could have went about this the longer way in knowing the interior angle sum that we talked about back in section 1, and then adding 85 plus 2x has to equal 360, and go about that way to solve for x. But just know, since J and M had to be congruent, they couldn't add to be 180. So that's why we had to use that leg side instead of the base, and that just had to add to give us 180. All right, in number 2, it says if EG equals FH, is trapezoid EFGH isosceles? So they are talking about this guy, EG, and FH. So they are talking about our diagonals. And it is saying that these two are equal. So yes, we can deduce that this is a trapezoid, or I'm sorry, that it is isosceles because of our isosceles trapezoid diagonals theorem. So I'm going to abbreviate a little bit. The isosceles diag theorem states that diagonals must be congruent. To be isosceles. And then number 3 says if the measure of angle HEF is 70 and FGH is 110, is the trapezoid isosceles? So I see probably the biggest issue with this part when it comes to these angles of making sure you're looking at the right piece. So it says angle H to E to F. Okay, so it is talking about this whole measure here, this whole thing. And then it is also talking about angle F to G to H. And it is saying this whole angle here. So it is saying this angle is 110 and this angle is 70. So we need to determine if this is isosceles. Well, we know that this top piece and this bottom piece are parallel. So that means that this angle and this angle up top should be congruent. And then this angle at bottom and this angle over here at the bottom should also be congruent. And if we do the math side of it, again, remembering that these side angles need to add to 180, we do see that to be true. So yes, angle GFE is 70, and angle HEF is congruent to angle GFE. So that is just showing that those top two angles are both 70. They're both congruent, which is one of the things that we have to have in order for our trapezoid to be isosceles. And then our last thing to look at is this mid-segment concept. So this mid-segment, I told you it would come back in kind of after those definitions up top. So now we actually have the theorem. So this theorem states that the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So to really see this as an equation, because I feel like that's a little helpful to see what this is actually saying. So the mid-segment, MS, is equal to, in this case, just for you to kind of see it because it works for these examples, I'm going to say top plus bottom divided by 2. Now, it's not always going to be true that your bases are the top and the bottom. Like I said, sometimes your trapezoid will be sideways. So in that case, the technical equation is base 1 plus base 2 divided by 2. So base 1 plus base 2 divided by 2. Okay? So in our last two examples we have here, it says in the diagram, MN is the mid-segment. So this guy right here is the mid-segment of trapezoid PQRS. And we need to find the measure of MN. So to do that, that's an N. MN equals our top measurement plus our bottom measurement divided by 2. That is how you find the measure of your mid-segment. So 28 plus 12 is 40. And 40 divided by 2 is 20. So MN is 20 inches. So it's pretty easy when you are finding the mid-segment, but in some cases, you were given the mid-segment and you actually have to find the measure of one of your bases. So in this case, on number 2, that's exactly what we're doing. They gave us the measure of the middle, but we need to find one of our bases. So whatever base we are looking for, I just label that as X because it makes sense when we are making our equation. So still use the same formula for finding the mid-segment and just plug in all of your stuff. So normally, mid-segment equals top plus bottom divided by 2, okay? So our mid-segment in this case is 18.7. So our mid-segment equals our top of 11.5 plus our bottom, which is just X, divided by 2. So I kept the same mid-segment formula. I just had to kind of plug in the things that we knew instead of actually trying to find that mid-segment. So at this point, we need to solve for X. So first thing that we're going to have to do is get rid of this fraction. So we're going to multiply both sides by 2. So then that is going to give us, 37.4 equals 11.5 plus X, right? Because these 2's over here just canceled. And so then at this point, we just have to subtract 11.5 from both sides. And that tells us that X equals 25.9. And X was our AB. And it doesn't look like they gave us measurements on this one. So AB is 25.9. And that is all for today. Next week, we will get into kites. That is our last special type of shape that we have to go over. And then I will be there on, let's see, I will see you guys on Tuesday. I will definitely be there Tuesday. So if anything hasn't made sense from the past few classes, definitely come with questions. I will be happy to answer anything and everything. Come see me during Empower Hour Monday. I also plan on being there Monday. Just anything you guys need. Also, feel free to email me with any questions you have at all. You guys do have an activity and a homework assignment to do. Both of those will be due next week. So make sure you get both of those done. If you finish everything, then you may work on something else. Or if maybe you're missing any work, make sure you kind of get that in. If you still need to take that Chapter 7 quiz, maybe kind of go over your stuff for that. The quiz was over section 7.1, 7.2, and 7.3. So we definitely want to get those in as soon as possible, just so you don't forget that information. But if you guys have any questions, feel free to email me and I will help you out.